All right. The seller of a loaded die claims that it will favor the outcome 6. So if you roll a die, you're more likely to get a 6 than anything else. We don't believe that claim, and we roll a die 200 times to test an appropriate hypothesis, and our p-value turns out to be 0.03. So which conclusion below is correct? A, there is a 3% chance the die is fair. B, there's a 97% chance the die is fair. C, there is a 3% chance that a loaded die could randomly produce the results we observe, so it's reasonable to conclude the die is fair. Or D, there is a 3% chance that a fair die could randomly produce the results we observed, so it's reasonable to conclude the die is loaded. Alright, so which one would you choose? Well, if you chose A, incorrect. B, well, C. The correct answer would be D. When we do an hypothesis test, we assume the null hypothesis is true. In this case, we assume the die is fair. And then we will reject the null hypothesis if the p-value is less than 0.05. And rejecting the null hypothesis means that we're concluding the die is not fair. So, if we assume the die was fair, there's a 3% chance that a fair die could get these results. So it's reasonable to conclude the die is loaded. So what is a p-value in general? Well, again, we always start off if the null hypothesis really is true, and any differences from sample size is just random chance. The p-value is the likelihood we could have gotten the value from our point estimate or value or something more extreme than our point estimate. If this likelihood is more than 5%, more than 0.05, then we'll consider random chance is a plausible explanation for the sample. So we would fail to reject the null hypothesis. If the likelihood is less than 5%, less than 0.05, then random chance is not a plausible explanation. We should fail to reject the null in favor of the alternative. Alright, so an example. Deborah Toohey is running for Congress, and her campaign manager claims she has more than 50% of the district's electorate. A newspaper collects a simple random sample of 500 likely voters and estimates Toohey's support to be 52%. Does this provide convincing evidence for the claim that the claim of her manager at the 5% level? So let's go ahead and start off with the conditions. So the first condition is, do we have a random sample? And yes, so we can claim independence because we were told in there was a random sample. The other condition is sample size. 52% of 500 is 260. 48% of 500 is 240. We have at least 10 of each, so the sample size condition has been met. Now, to actually do the hypothesis test, we'll assume the proportion is equal to 50% for the null hypothesis. The alternative is not equal to 50%. And what we do is that we'll reject the null hypothesis first if we can. Then we'll worry about whether she has more or less than 50% of the vote. The point estimate was told to be 52%, and it was a sample size of 500. So the standard error, square root of 52 times 1 minus 0.52 over 500. Square root of 0.52 times 0.48 divided by 500. We get a standard error 0.0223. Now the test statistic, 0.5, null hypothesis, the point estimate minus the null value over the standard error. So 0.52 minus 0.50 divided by 0.0223. So parentheses 0.52 minus 0.5 divided by 0.0223 gives us a test statistic of 0.897. To find the p-value, we take that 0.897 and we'll use the normal CDF command. So second vars choose a normal CDF. And the test statistic, 0.897. Upper level, just pick something large, like 999 is more than good enough. 0.1, paste. And then times 2. We find our p-value is 0.3697 or 0.370. This is more than 5%, so we should fail to reject the null hypothesis. So we don't have any evidence that she has more than 50% of the vote. So we have no evidence that she has something different than 50%. She may have more than 50% of the vote. She may have less. I can't rule out the results of random chance.